Okay, so now I'll continue with exercise 2.2. Question number 5th onwards, you are asked to reduce into simplest forms. That means we'll simplify. Now here in each of remaining questions, mainly you need to take some trigonometric functions in such a way that this should be reduced into 10 because outside you have 10 inverse. So what we do is here, 1 plus 10 square is x square. To remove this, so we put here x equals to 10 theta substitution. Why we have chosen this substitution? Because we know 1 plus 10 square is 6 square. That's the main reason choosing this 10 theta. So tan inverse, this is 1 plus 10 square theta minus 1 upon 10 theta. Now we simplify with the help of Trigo functions, and this should be in form of 10, and then tan inverse 10 will get cancelled. So this is tan inverse sec theta minus 1 upon 10 theta. Now you reduce into sine cos. So this is tan inverse 1 minus cos theta upon sine by cos, and then cosine will get cancelled. So we have this. Now you know very well from Trigo, if you recall half angle formula, this is 2 sine square theta by 2. Just recall this. Sine square alpha by 2 equals to 1 minus cos alpha whole by 2. So I place this much value. So it is 2 sine square alpha by 2, half of the angle. And you know sine x formula, which is twice sine x by 2 into cosine x by 2. This much also you know. So here I'll place this. So this is 2 sine theta by 2 into cosine theta by 2. So this 2 will get cancelled, 1 sine will get cancelled. So this is tan inverse just tan theta by 2. 2 will get cancelled, sine will get cancelled. Now this will get cancelled, right? That was the main objective. Here outside you had tan inverse, so we need to reduce this bracket into 10, and that's why we have chosen x equals to tan theta substitution. Okay, now this will get cancelled, so you are just left with theta by 2. So 1 by 2 as it is, as x equals to tan theta, so theta equals to tan inverse x. So this is tan inverse x. Theta equals to tan inverse x. That is the reduced form of, or the simplest form of, the given expression. Question number 6 is here. Tan inverse 1 upon root x square minus 1. Now again we use Trigo identity. You recall x square minus 1 identity. So you can use this. Sec square theta minus 1 equals to tan square theta. You know this. Or you can use cos x square minus 1 also. So we put x equals to tan theta sec theta substitution here. Right? We use this identity, or we have this identity in our mind. Let's put this. So tan inverse, this is 1 upon root of sec square theta minus 1. So this is equals to tan inverse 1 upon sec square minus 1 is just tan theta. Now this is tan inverse, 1 by 10 is cot theta. Now these two functions should be same. So instead of cot I need tan. So I can rewrite as tan inverse tan pi by 2 minus theta. You know this. Tan pi by 2 minus theta is cot theta. Now this 2 will get cancelled here. So this is just pi by 2 minus theta. And here theta will be sec inverse x, So therefore this is pi by 2 minus sec inverse x. This is a simplified form. Next question, if I go to 7th here, question number 7. So there you are given tan inverse root of 1 minus cosine x upon 1 plus cos x. Now again this should be reduced into tan function. And you also know this is a standard Trigo formula, if you remember. So this is tan inverse root of tan square x by 2. That you know tan square alpha by 2 is 1 minus cos alpha upon 1 plus cos alpha. That half angle formula from alpha to alpha by 2. So I've used this. So this is equals to tan inverse. You have modulus tan x by 2 here basically. You know this root of x square become modulus x. Now this is tan inverse of tan x by 2. Why this? Because you look at condition 0 less than x by 2 less than pi by 2. So 0 to pi by 2. This is given in the data, remember. You are given 0, x and pi dividing by 2. So 0 x by 2 is in 0 to pi by 2, which is first quadrant. And first quadrant tan is positive, so it is free from modulus. Now this will get cancelled. So x by 2 is your answer here. That's a simplified form. Next question, question number 8 here. 8th question, that is tan inverse of 1 cos x minus sin x upon cos x plus sin x. Now I want to reduce this one into tan function because outside I have tan. That's what you did here, same thing here. Outside your tan inverse reduce into tan. So what I'll do is I'll divide numerator and denominator by cosine. Dividing this by cos function, dividing this by cos function. So cos by cos 1 minus sin by cos 10 upon cos by cos 1 plus sin by cos, which is 10. I repeat what I did here, dividing numerator and denominator by cos function. Why I did this? Because I need tan function. Sin by cos, 10. Why we need tan function inside the bracket? Because outside you have tan inverse. Tan inverse and tan will get cancelled. Now this is from again 11th standard. This one you can imagine as tan pi by 4 minus tan x as it is. 10 pi by 4 is 1 upon 1 plus, here you can imagine 1 into, that is 10 pi by 4 into tan x. So this is tan alpha minus tan beta upon 1 plus tan alpha into tan beta. So here inside the bracket you will get the tan pi by 4 plus x formula. This 11th standard Trigo. I repeat, if I expand this is tan pi by 4 1. Sorry, here I minus in the numerator, so this must be minus. Tan pi by 4, which is 1, minus tan x upon 1 plus tan pi by 4, which is 1 into tan x. Now this will get cancelled, which is pi by 4 minus x. Right? So this is the simplified form. 9th question. Tan inverse x upon root of a square minus x square. Now if you have a square minus x square, then here I can take x equals to, if you have for example 1 minus x square, you can put here x equals to sine theta. So 1 minus sine square, that gives you cos square, so it will be free from root. But I have a here, so it's like a square minus x square. So here I need to take a with this, so we'll put a sine theta. Why we have chosen a, you will realize, because now this is a square sine square, so a will come out from this. So this tan inverse a sine theta upon, this is a square minus a square sine square theta. Now take a square common, it will come as a and it will get cancelled with the numerator and denominator. So this is just sine theta. Take a square common from this 2, so it will come as a and internally it will get cancelled. So inside the bracket you will get the 1 minus sine square. So this is just cos square, and outside the square if you take it, it is just cos theta. So here you will get the tan inverse sine theta upon cos theta, which is tan theta. This will get cancelled, internally, so this is just theta. And here you can find theta from this. So sine theta from the substitution is x by a. So it implies theta will be sine inverse x by a. So final simplification is sine inverse of x by a. This is the most simplified form of the given expression. So here in the next question, inside the expression, it's look like this. If you remember, 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, if you recall. And you know that this is just a formula of tan 3 theta. So in this formula you need 1 here, that means this a cube should get cancelled with the numerator and denominator. So what we do here, we are going to put here substitution x equals to a is there like the previous question. So not only tan theta, but we put a tan theta as a substitution. So if I use this is tan inverse 3a square into a tan theta minus a cube tan cube theta upon a cube as it is 1 minus 3a, what is the x here, a tan theta. So this is a square tan square theta. Now this is a cube, this is also a cube, this is a cube, and this is also a cube. So you take a cube common from numerator, take a cube common from the denominator, so it will get cancelled. So finally we'll get the 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. I repeat what I did here, taking a cube common from numerator, taking a cube common from the denominator, and within the bracket it will get cancelled. So you are left with this. Now you know very well this is just tan 3 theta, and this will get cancelled. So you are left with 3 theta. And what is theta? Go back to substitution. Tan theta is x by a. So theta will be tan inverse x by a. So this is tan inverse x by a. So that's a simplified form, 3 times tan inverse x by a. So now 11th question onwards, you are asked to find the value. So we want the value of this expression. It would be a fixed number. If you start with innermost, sine inverse 1 by 2, So here this is 2 times, this is pi by 6. You recall sine pi by 6 is 1 by 2. So therefore sine inverse 1 by 2 is pi by 6. So this is pi by 3. Tan inverse 2 times cosine, this is pi by 3. 2 and 3. So, and cos pi by 3, it is just 1 by 2. So this is tan inverse 1, and we also know that tan inverse 1 is pi by 4. So the value of this expression is pi by 4. Question number 12, if I go to 12th question, you are asked to find cot of tan inverse A plus cot inverse A. You know very well that this is just pi by 2. three results: sine inverse plus cos inverse pi by 2, tan inverse plus cot inverse pi by 2, sec inverse plus cosec inverse is pi by 2. So this is just pi by 2, a result. You know this. And what is cot pi by 2? You know it is 0. So value is 0 here. Next question, question number 13. We want the value of this tan of 1 by 2. Inside the bracket we have sine inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. This is tan of. So we simplify this here and we get the value. Now here you know that this is a standard Trigo formula, 2 tan theta upon 1 plus tan square. So we put here substitution. Let's put x equals to tan alpha, and you know 1 minus t square upon 1 plus t square. So I'll put y equals to tan beta. You cannot use same angle, so here I've used alpha, here I've used beta. So this is equals to, this was our substitutions here. So tan of 1 by 2, this is sine inverse 2 tan alpha upon 1 plus tan square alpha. This is cosine inverse 1 minus tan square, 1 minus t square if you remember, upon 1 plus t square. So this is equals to tan half. This is sine 2 alpha formula. So sine inverse of sine 2 alpha plus this is nothing but the cos 2 beta formula. You know cos 2 beta is 1 minus t square upon 1 plus t square. Sine 2 alpha is 2 tan alpha upon 1 plus tan square alpha. This will get cancelled internally. This will get cancelled internally. So we are left with this 1 by 2, 2 alpha plus 2 beta. Take 2 out, it will get cancelled with this. So this is just tan alpha plus beta. Now you can just use addition formula here. So this is tan alpha plus tan beta upon 1 minus tan alpha into tan beta. But you know from the substitution tan alpha is x here, tan beta is y here. So this is x plus y upon 1 minus xy. This is the simplified form. Your question is in form of x and y, so it has to be reduced in x and y, remember. So you cannot keep in this form. So placing values of tan alpha and tan beta from here, x, y. So 1 plus xy upon 1 minus xy. This is your final reduced value. So here next question is get the value of x. That's the question. Find x. So I'll take first sine on the other side. So this is sine inverse 1 by 5 plus cos inverse x. If I take sine on the other side, it becomes sine inverse 1. So this is sine inverse 1 by 5 here plus cosine inverse x as it is. You know that this is pi by 2 because sine pi by 2 is 1. I'll take this one on this side now, equals to, this is pi by 2 minus cosine inverse x. Now this is again known to us, which is nothing but the sine inverse xy because of this property. Sine inverse x plus cos inverse x equals to pi by 2. So this implies sine inverse 1 by 5 equals to this. So this sine inverse will get cancelled. So 1 by 5 equals to x. This is the final answer. Next question, 15 number, which is an important example. You are given tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 equals to pi by 4. Question is same, we want the value of variable x here, that's the question. So first you imagine this like x and this like y here. So tan inverse x plus tan inverse y formula. So this is tan inverse x minus 1 upon x minus 2 plus x plus 1 upon x plus 2 upon 1 minus x minus 1 upon x minus 2 into x plus 1 upon x plus 2 equals to pi by 4, right? You know this formula, tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. We have used this. So this bracket is like x, this bracket is like y. You take tan inverse on the other side, so this is tan pi by 4, which becomes 1 in turn, taking tan inverse on the other. Now here we simplify, we just take the cross multiplication. So x minus 1 into x plus 2 plus x plus 1 into x plus 2 upon 1 minus, this is x square minus 1, and here LCM is x square minus 4, so x square minus 4, and that x square minus 4, x minus 2x plus 2, that x square minus 4 will get cancelled from numerator and denominator. Now you just simplify this, this is 1, so you'll get the value of x finally, right? This is what you need to do. I repeat this portion, x plus y upon 1 minus xy. Take cross multiplication, so here LCM is x square minus 4. After taking x square minus 4 LCM with this, it will get cancelled from numerator and denominator. Now this portion you can simplify, tan pi by 4 is 1. This tan inverse I have taken on the right hand side, so tan inverse becomes 10. So this is 1. Now you just simplify this, so you'll get the value of x.